green. As green is what we want. Okay. All right. So today I'm going to talk about the issue that came up a lot last time about whether there's a joint in nature between perception and cognition. So I'll try to say why I think there is a joint. And maybe if I get time, a little bit about what I mean by a joint, although I don't know if there'll be time for that. Okay, just to remind you from last time, I presented this picture that is more or less what is in Tyler Burge's 2010 book. And I argued for a kind of seeing as that is non-conceptual. The idea is that in a percept, you have a singular element and a general element. That general element is itself a kind of seeing as that needn't involve any concepts. It could be the same in insects as in us. And then it's conceptualized in a basic perceptual judgment. So by concept, I mean a mental representation that is part of a thought system. Concepts go with thinking. Non-conceptual representations go with perception. There may be other kinds of non-conceptual representations too, perhaps in location systems. What I said was that the difference between, the key difference really is this format difference, that perception is constitutively iconic. Cognition is at least in part non-iconic. Now, cognition can be iconic too, or partly iconic, when you are using a mental image in your thought. You image something, and you may say you image a piece of furniture and use that image to decide in your reasoning whether it will fit through a doorway. So it's not that cognition cannot be iconic. By the way, let me say, feel free to ask a question or make a comment any time. I don't consider it interruption. If it's a major issue, then I'll postpone it to the end. But I'm not too concerned about going all the way through without. Is that a question? It's a hand. Okay, so I mentioned these other features of computational role. Perhaps the most unfamiliar is this idea that in perception, the representations of a property function. This is a Burge's way of putting it. They function to get the demonstrative element to the referent. It's not real predication. It is, if you see something and you're placing a feature in an area or on a thing, the function of the property representation is to help the demonstrative to refer to the thing that has the property. So these I went through last time. I won't go over them again. So here is the order of business for today. I'm going to talk about the new look of in perceptual psychology of the 1940s and 50s, and then I'll just briefly mention the new look. And then I'll go into the main ideas of why we should believe in a joint in nature. And then I'll say a little bit about the question, actually this is a quite crucial question of what top-down influences are compatible with a joint in nature. And then I'll end with talking about core cognition. Those of you who were at Susan Carey's lecture a year ago will have heard about core cognition. I'll remind you a little bit about what core cognition is and why many people think it shows there's no joint in nature between cognition and perception. This is especially prominent in a recent paper by Nick Shea of King's College London, who uses core cognition to argue against a joint in nature between perception and cognition. And I'll say a little about why I think his argument doesn't work. Okay, so that's the order of business. Oh, let me turn off my phone, and you can turn off your phone too. Everybody has a chance to turn off their phone. Okay. Okay, so first of all, the new look. Okay, so here is a little cute demo of the new look. So all you have to do is watch. Very quickly presented things. What are they? Okay, let's hear it. Let's hear it this time. Okay, so now I don't know how many of you saw that as a red six of spades to begin with, but according to the famous Brunner-Postman experiment of 1949, you really experienced that as a normal six of hearts. So their idea was, I mean, they wouldn't say non-conceptual, but I say no, they had a genuine experience of a red six of hearts. The opposite view, the one that I hold, is you actually had the experience, the non-conceptual experience of the red six of spades, and then there was a post-perceptual judgment of it as a six of hearts. Sorry, I forgot to mention the finding of the experiment. The finding of the experiment is you show people these fast presentations, and including some oddball cards like the red six of spades, and they say six of hearts. Okay, the subject says six of hearts. Did he really see a six of hearts? So here's the thing. The new look, it was soon pointed out that there are many experiments of this type, and they simply did not control adequately for the difference between a perception and a perceptual judgment. They did not use there was not much of methodology available at the time, but what little there was, they really were not attentive to that difference. And once people realized that, the new look faded away. And then in the 1980s, we had The Modularity of Mind by Jerry Fodor, but this is leading up to that and they argued, they introduced the idea Fodor and Plyushin introduced the idea of cognitive penetration of perceptual experience. Plyushin defines it like this: if a system is cognitively penetrable, then the function it computes is sensitive in a semantically coherent way to the organism's goals and beliefs. That is, it can be altered in a way that bears some logical relation to what the person knows. Okay, so, and the leading idea of this, the one that really captured people's imagination, was the very straightforward fact that all the standard illusions, and in fact, all the normal visual illusions that you read about in a textbook are like this. I can't really see what you're seeing there, but they look, so these lines look equal, look unequal, but they're equal. Okay, so here you have the measurement. You can see that they're equal, but they still look unequal. You can know all, it's the problem of known illusions, an illusion where you can know it's an illusion and the illusion still works. So if your beliefs and expectations influence your perception, why wouldn't they get rid of that illusion? So that's sort of the motivating idea of this modularity, but combined with a lot of evidence. Then, about maybe 15 or 20 years ago, we had the beginning of what is sometimes called the new look. And I've just picked some pictures at random of people, but the first of many of these people, these three, are part of Dennis Proffitt's lab, and they have many experiments that purport to show all kinds of psychological and social effects on perception. And there are some other people, including the philosopher Fiona McPherson, who's argued for this. And then we have the anti-new look, and the key players in this, I think. If you don't know this literature, and you're interested in the philosophy of perception, you really should go to Chaz Firestone's webpage. He is a graduate student in psychology at Yale University working with Brian Scholl, and they have some absolutely wonderful papers debunking the new look, with very powerful demonstrations of why many of the paradigms of new look, the idea that that cognitive penetration of perceptual experience do not work for various systematic reasons. I'll mention a couple of their points today, but I won't have a chance to go into them. And their papers are all on Chaz's website and also Brian Scholl's website. The work is basically Chaz's work. He started this work as a first-year graduate student. In fact, he started the work before he became a graduate student. And in Brian Scholl's lab, the work has developed enormously. He was a philosophy undergrad, and the work is very philosophically sensitive, including the isolation of some amusing fallacies in the reasoning, philosophical fallacies in the reasoning of the psychologists like Prophet who do this work. It's quite interesting from a philosophical point of view how the philosophical perspective can be applied to these experiments. Anyway, it's very, very nice, well-written, well-reasoned material, so I recommend it. So why should we believe in a so that's the historical part, quasi-historical. So why should we believe in a joint in nature between perception and cognition? Well, first of all, we have these methods that I went over last time, and how many people here today were here last time? Almost. How many weren't here? It'll be easier to see. Just a few. Okay. Maybe I will just, I feel that people need to appreciate this okay, so I mentioned various methods for testing whether something is a perceptual representation. And basically the idea was you test whether a representation is perceptual by ascertaining whether it participates in perceptual phenomena. And I mentioned that this looks circular, but then I said you could find tests that group together. There's one of these that's going to figure in what I'm going to be doing, so I really feel like I maybe should present that for those who weren't here. I'm sorry for those who, so this is going to be important when we talk about core cognition. So those who weren't here last time, please stare at that red dot. I'm going to spend 30 seconds on this. I'm sorry for those who were here. So stare at that red dot very intently, and then I am going to give you a display, and you have to say the words more on the right, or just say the words right if there's more on the right, or left if there's more on the left, okay? So the idea is you're going to see a display, and maybe one will look like there's more than the other, and you have to say right for more on the right or left for more on the left. Okay, you ready? 1, 2, 3, go. Okay, right? So what happened here, it's this. It's that you saturated your channel, so you have perceptual sensitivity to approximate number. This is one of the amazing demos of that. So you have these perceptual channels that were for high numerosity of fatigue, got fatigued, low numerosity got fatigued, and so when you saw these things that were equal, this one looked like more. Okay, so that's the explanation. The key fact here is that it shows, or provides evidence, and there's more evidence, that you have an actual perceptual representation of number. Now, the reason this is important for thinking about core cognition is that perceptual representation immediately functions in cognition like a representation of approximate number. And so there's the issue of whether it somehow provides that fact of immediate built, well, I'll get to why it is. No use getting ahead of the game here. Okay, so so we have methods of determining whether an effect is perceptual. They seem to work. So that suggests at least the perceptual side of the joint in nature can be actually nailed down experimentally. We know, we have a pretty good idea of what a perceptual phenomenon is. It's a lot harder to nail down the conceptual side, but at least we've got one side of it. Okay, so paradigms of supposed cognitive saturation of perception. I'm going to show you a few of the experiments that have been much in the news. Oh, I left one out. Damn. Okay, I'm sorry. I'll just say it. I think it's in this. It's actually in this file somewhere. But okay, so this is work, a very famous work of Dennis Prophet. So you had people stand in front of a hill, and they could either be wearing a heavy backpack or not. And what the subject's task was to estimate the angle of the hill. Okay. And what they found was, if they were wearing a heavy backpack, they estimated the hill as steeper than if they were wearing a light backpack or no backpack. And they had many different methods of estimation. They could go like this, or they could say, 45 degrees, or various other things. Okay, so this, very well done experiment in a certain respect. However, Frank Durgan, who's another of the debunkers, also a very good debunker, he did what Prophet regards as a pathetic version of it with instead of a hill, he had various inclined planes and an office. However, what he showed, but he was able, here's the thing, this is the gold standard of disproof. It's replicating the effect and then not replicating it if you change the situation. So he replicated the effect with a heavy backpack, and then he attached another condition. He attached wires from the backpack to the subject's legs with taped on, and told the subjects that the purpose of the backpack was to contain machinery which was to measure the muscle force in their legs. And then the effect went away. It's a very cool thing that you can do if you can replicate the effect and then non-replicate it. And as with many effects in social psychology, look, you could look at it as a kind of trivial thing, because I didn't control it very well. But the thing is, there are systematic problems like this in this literature, where systematic failures to properly distinguish between perception and perceptual judgment. Judgments are we very well known, are influenceable by the expectations that the experimenter sets up. So it suggests this is an experimenter demand effect, and further experiments, I believe, strongly suggest that it is an experimenter demand effect. I should say that Prophet has replied, and you can read his reply in 2009. I'm sure you can find that on his website. Okay, here's another really interesting experiment. This is one of the really the prime experiments in this genre by Levin and Banaji, and they showed that if you matched different race faces for mean luminance, they were perceived by subjects as having different lightness anyway, okay, because of the race. So the Caucasian-looking face was perceived as lighter even though the mean luminance was the same. Okay, so luminance is the objective intensity per unit area, and lightness is the visually precise. It's the lightness that the Caucasian face looked lighter. And here's the thing: you can see it in the picture. Okay, at least I don't know if it's visible in your picture, but in a properly presented picture, it is. It's actually visible. And as this is one of Brian Scholl and Chaz Firestone's experiments, and as they say, it is to our knowledge the only purported top-down effect on perception that readers can experience for themselves simply by looking at the stimuli. So just to remind you, if you go back to this Prophet thing, when they put a heavy backpack on you, nobody reports that the hill suddenly looked steeper than it did. These effects, except for this one and a few others related to it, they are not observable by a subject. In fact, Brian Scholl has a very interesting take on this. He said, when he first started reading about this, he thought, well, I'm a perceptual psychologist. I'm a vision scientist. the touchstone for vision science is you can see the phenomenon yourself. You know, I've shown you a number of phenomena already. This is what you get in vision science, at least hopefully. You get phenomena you can see yourself. Nobody sees these themselves except for this one. Okay, and a few other related. So here's what they did. They had the idea there was something wrong with the setup. So what they did was they blurred the faces, okay? And they got the effect on the blurred faces, okay? And I don't know if you can see it, that this blurred face looks a little darker. Okay, now you might think, oh, that's just because they didn't blur them enough. Because they didn't blur them enough because you can still see the indications of race in the pictures. So here's what they did to rule that out. They had all these things that I've listed here. They asked people to describe the picture, and if they said anything about race, they threw that data away. They told subjects that they were faces and asked for another description. Again, if the subject said anything about race, they threw them away. They said, are these different races or the same? If the subject said different races, they threw it away. If they said, they said, do you think this experiment might be about race? If the subject said yes, they tossed that data out. Have you previously participated in an experiment that involved blurry faces? I don't know what this is for, but anyway, so, and the results were, even throwing away all that data, in two different versions of the experiment, you know, somewhere in the vicinity of 70% counted the left blurry face as darker or the right one lighter. Okay, so the thing is, you know, yeah?
Did they ask, so in just one of them, whether these correspond to Afro-American or a Caucasian person?
No, not that I know, but they did ask all these questions about race, so that's a different way of asking that. It's an experiment, you know. Experiments always use certain procedures. You can always say, oh, I would want a different procedure. And you know what? You can actually do the experiment yourself. I'm sure you get their materials. They're very good about giving away their materials, and everybody can do the experiment. Anyway, again, it's a primo thing, one of these primo examples that has made people think that cognition, there is no joint in nature between cognition and perception. And this is a general feature of these experiments that are supposed to be the anti-modularity experiments. When you focus, of course, look, every experiment can be criticized. So this is, you know, of course, you know, but these are not just criticisms. They show systematic problems. And they've done this now. If you look on their website, they've done this now for quite a number of things. Now, it's important to see, though, that the issues here are not just issues to do with bad experimental procedure. Here is a really interesting case. So this is, I think this goes back maybe almost 100 years. I'll explain. One of the things that people have noticed is that there seem to be very clear, strong cognitive effects for color. Okay, you know, I mentioned the memory color point that I made before, but those kinds of effects are just ubiquitous and have led people who study color to think color is just very, very cognitive. And there's a paper by Fiona McPherson that advocates cognitive penetration that goes through some of these experiments, although not this one. Okay? Now, this is like the gold standard of experiments on cognitive penetration of color experience. And it's in Gegenfurtner's lab. They have done like 4 or 5 of them over a 5-year period. And basically the upshot, I believe, according to me anyway, the upshot is unambiguous, but I'm going to get to it. So here is their basic paradigm. It's very cool. They take pictures of common objects. In this one, it's fruits and vegetables. And the pictures can be a random color. And then the subject has some, I don't remember quite what the dials are, but they're either 1 dial or 2 dials, or 3, I don't remember how many dials there are. Anyway, the subject has to take that picture and adjust it so that it looks neutral gray. Everybody understand that? You make the picture look gray. Now, I won't go into what this diagram exactly means, but these are component process measures that you don't need to know about. But the basic idea is that for yellow things, like a banana, when the subject makes it neutral gray, they're making it objectively quite blue, okay? So you show a person a randomly colored picture of a banana, and they say make it gray, and it ends up being pretty damn bluish, okay? Suggesting that the memory of the yellowness of a banana is having an amazingly huge effect. It's superimposed on the gray of the picture, and making, so they have to make it blue to counteract that. Everybody get the idea of it? Okay, so they did a wonderful, there's a whole lot of experiments, and I'm just going to show you kind of one thing, but they all point to an interesting phenomenon. And the phenomenon, I think, shows that this is not a cognitive effect. How could that be? Well, here's the thing that kind of, oh no, what's happening here? Microsoft error reporting, yeah. Okay, let's see. This is my, I'm having a lot of trouble with PowerPoint. Okay, where is this? Okay, here it is. Good. Okay, so here's what they did. They gave the subjects a whole lot of, and this was really visible on the data I already showed you, but you probably didn't notice it, especially since I didn't explain the diagram, but this is much more. So here is, they gave the subjects all kinds of common objects, which have fairly stereotypical colors. So, for example, this is done in Germany. This is people tell me this is a very prominent blue object. You know, worldwide, this is a very prominent red object. Another one, very prominent green object. In Germany, apparently, this is a very prominent yellow object. You get the idea, right? So they did this experiment with people, and here's what they found. They found a substantial memory color effect for certain things, okay? Now, there's a kind of regularity there. If you look, I outlined them in yellow. Notice it's all the yellow and blue things. It's not the green and red things. For the green and red things, they got little or often a negative memory color effect. What the fuck is going on here? So here's the basic idea that I believe, you know, this is, my interpretation may be a little controversial, but I don't think so really. What they found is that this is an effect that occurs within the visual system. And I can show you some of the interesting experiments they did that suggest that. It is a purely visual effect. It is not a cognitive effect. If it were a cognitive effect, like our expectations about the ordinary colors of things, you would expect it to work just as well for red and green as for yellow and blue. Okay, so they have an account of why yellow and blue and not red and green, but it's a visual account. And they have a number of experiments. If somebody wants to ask a question, I can explain a bit more, and I actually have some of the slides from some of their stuff. So, and this is an important type of phenomenon. There are many phenomena that look like cognitive effects on perception, and they're actually effects within the perceptual systems. And the idea is there are association networks within the perceptual systems that associate color with shape, with texture, with 3D shape, 2D shape and 3D shape. And so those effects seem to be causing this. Okay, so let me go on to, here's another reason that this is all under the heading, Why Believe in a Joint in Nature. So this reason is perceptual systems have their own logic, and I'll just say a little bit about that logic. Okay, here's a kind of cool display. I actually got this from a paper by Britt Brogard. So look, you see three objects, and one of them has part of it occluded. So, but the ones on the side, they're standard stop sign shape. Why don't you see the middle one as the stop sign shape? Okay? You think if like expectations or prior probabilities, you would think that, but it doesn't work that way. The visual system has its own logic. It doesn't follow what you believe or would reason. So, and this is a general feature. Many perceptual systems just operate according to their own logic. They don't follow principles of rationality. So here's a kind of cool thing which many of you may know. This is really, maybe I shouldn't be showing this but I can't resist. This is the hollow face illusion. How many have seen this illusion before? It's quite a cool illusion. So there's a rotating mask, and you'll see you cannot help seeing the damn thing as a face, even though as a normal face, more or less normal. But look what happens there. So it just pops out at you. So even though your beliefs are that it's a mask, you see it as a face. Okay, here is an interesting phenomenon that reflects a quite general feature of perception. This is the famous size-weight illusion, which is that if you have two things of equal weight and you hold them in your hands or pick them up, and you're looking at them, the little one feels heavier, okay? Have people heard of this illusion? Here's the thing. It's interestingly anti-Bayesian. It's the opposite of your expectations. You expect the little thing to be lighter, right? But it feels heavier. So, it seems like your priors are it's going opposite from your priors. It used to be thought that it was due to a contrast, that is, you're holding your hand out and you expect it to be lighter, and then when it's the little one, when it's lighter, when it's heavier, you're somehow the difference between your expectation. But actually, it works for a passive hand. You can put it on a hand on a table. So that seems like that isn't the explanation. Some really interesting experiments done on this by Mel Goodale in his lab at the University of Western Ontario. And he notes this powerful illusion does not lessen after prolonged experience with the stimuli, and even persists when the individual is told that the stimuli have the same mass. So the size-weight illusion looks to be either a feature of our experience in the world, or maybe it's even innate. But it doesn't seem to change in an online way. Now here's an interesting phenomenon when you combine, there's something called the materials weight illusion, which works similarly to the size weight illusion. And so Goodale combined them, and he thought that he would get a combined effect. So here's what he did. He had these silvery objects and styrofoam objects of two different sizes, and he asked subjects to rate their expectations for the weight of these objects. And what you see in the screen is that this is the high density, and this is the high density being the metallic ones, low density being the styrofoam ones. So, and this is size, and this is estimates of mass. And not surprisingly, they thought that as the size got bigger, the things would be heavier. And they thought that the metallic one would be much heavier than the styrofoam one. Okay, those are the subject's expectations gained by asking them. And here's the paradigm he used. He got their prior expectation of weight, and then he had them lift. You see the handles on the top? They can lift those things up. And he had a cool device so that they couldn't see their hand. They could see the object, and then once their hand gripped it, this thing cut off the vision of it. So they lifted them 10 times, and they made a perceptual judgment about which things were heavier and which things were lighter. So here's what he says. Prior to starting the experiment, subjects expected the density of the metal cubes to be higher than that of the polystyrene cubes. Their illusions, however, did not reflect their conscious expectations of heaviness. Instead, subjects experienced the size-weight illusion of the same magnitude regardless of the cube's material. So there was no effect of materials on their judgments. Their expectations were based on size, but not material. So the visuals, the perceptual systems were throwing away the information about material. And again, this is a peculiar feature. It's a common feature that perceptual systems throw away a lot of information that you think could be used. Anyway, as he says, the finding strongly argues against the intuitive suggestion the illusion is caused by a contrast with sophisticated or veridical representations of an object's likely weight. Okay, I'm running short of time. Now you might object, aren't you assuming that the expectations that drive the perceptions are conscious? But here's the thing, if those expectations are built into the visual system rather than being part of the central cognitive system, that's like the color phenomenon. It's within perception. It's not a cognitive effect. And I think this is often a feature of these supposed top-down effects. They're often within modules. Just to summarize that, okay, so let's just summarize what I just said. So I'm going to skip ahead because I am taking too long. I'm going to skip so let me get to an important thing, which is, and this is something that I think has not been done in the literature, to try to explain what top-down effects are compatible with a joint. Okay, so I think there are 4 kinds that exist. They are top-down effects and they're compatible with the joint. First of all, diachronic effects. Okay, I mentioned this one, this effect of silhouettes you see on your figure ground segregation. Okay, that is not an online effect of cognition on perception. It's not even an effect of cognition on perception. It's an effect of your experience on perception. That does nothing to suggest that there is no joint in nature. Attentional effects. Okay, we're all familiar with this. You attend there, you see it one way, you attend there, you see it another. Spatial attention simply boosts the signal. And Marissa Carrasco, some of you may know, I'll get to this in a later lecture. She has showed some very interesting phenomena having to do with attention, and I don't have time to go into her effects. But her effects correlated with, in a brain imaging study, her effects correlated with increased activity in early stages of visual processing. Many of her effects are on contrast, and these areas are sensitive to the differences in contrast. And the larger the cortical effect, the greater the effect on judgments. So I'm going to skip more about attention, but I will, no, I have to skip that. So in addition to spatial attention, there's also feature-based attention, but that's not anything like an effect of seeing what you would believe you would see. Now here, these are cases that I think, to me, these are the strongest cases for an effect of cognition on perception. These figures where you don't know what it is and then you find out what it is and it kind of snaps into place. How many know what this is? It's probably one you've seen before. How many don't know what it is? Oh, you people who don't know what it is, you're going to have this is your lucky day, because you're going to get to actually experience the phenomenon. Okay? This, the thing is there are very few of these that really are good. This is the best. So you'll have an unusual experience, so you only have once. Okay, it is a Dalmatian dog. Check it out. That's the head. That's the body. Front legs. Back legs. Everybody see it? Okay, this is one of those things, the picture's a little elongated, so it may not be perfect, but now you can't unsee it. Okay? All right, so there it is. You know what it is, and it looks that way. How does that work? It really does seem to be a cognitive effect on perception. And the most plausible cases of cognitive effects on perception are cases with ambiguous stimuli. Okay? Those are the best cases, and this is one of them. Now, how can it be explained? First of all, nobody has an explanation of these phenomena. I don't know of papers that go into any. Maybe there are some that I don't know about, but I haven't seen any. What I would expect is that it is a combination of spatial and feature-based attention. When somebody says dog, your dog detectors go on. So we know that feature-based attention works across, it's a different kind of attention, works across the whole visual field. But, anyway, intellectual honesty requires that I mention this. I think it can probably be explained that way, but this is the biggest question mark in my talk and in the whole issue, if you ask me. Hysteresis. This is a phenomenon, the stickiness of perception, shown by Molly Potter using focus of pictures. And since I'm running out of time, I am not going to go into it, but I think, again, I believe that stickiness can obtain even if there's a joint in nature. Imagery. This is a more significant issue. So if you look at this grid, a 5x5 grid of dots with a missing dot, you find it very easy to locate the missing dot, right? Okay, but what happens if there's a partial grid followed by another partial grid in exactly the same place? Turns out people can superimpose those if they come close enough to each other. But even if they come quite far apart from each other, even seconds apart, it turns out subjects can superimpose the second one on the first. And the experiment that first demonstrated this is by Blackmole, Wang, and Irwin. And here's what they did. What they did is they just decided to wait a long time. And this is a nice graph of their results. So what they asked people to do, they had a first partial grid and then a second partial grid. The subjects were instructed to try to remember the first partial grid. The second partial grid stayed on the screen, and the subjects were asked to move a cursor to the missing dot. So they had to superimpose that first partial grid on the second partial grid to form a whole so that they could see the missing dot. And this line represents errors in the dots that were actually on the screen. Okay? So if they got wrong, if they identified one of the screen dots as the missing dots, which is pretty unlikely, but you can see that it wasn't totally 100%. And people, it's a, there were I don't know, people heard some noise or they had some event in their stomach or something. I don't know how that could happen. Here is so this is percent dots remembered almost 100% for the ones on the screen. What about the ones they were superimposing on that? Okay, at first, very early on, it's very high, and then in a few hundred milliseconds, this is interstimulus interval in hundreds, in milliseconds. This is 5 seconds out here, this is 500 milliseconds. Okay, in the first few hundred milliseconds, very immediately after it's high, because they fused the two. But then they go past the border of fusion, and it sinks to roughly 50%. So they're nowhere. Then it slowly rises after about a second and a half to the point where they're getting more than 90%, and they maintain that 90%. So they're able to remember that first grid, to form a memory image of it, and to superimpose it on the second. And I like this for two reasons. One is, it shows how good we are at forming a joint state of perception and imagery. And you might think, my God, this is incredible cognitive penetration. This shows we can see anything we want because all we have to do is imagine it. But here's the interesting thing that this experiment, and this is one reason why it's so cool, what it demonstrates. It takes a second and a half to form a mental image. This is the time independently calculated using other materials by Steve Kosslyn in his work on imaging. Kosslyn, if you don't know, is like the god of mental imagery. He's got tons of experiments on it. And a second and a half or a second to a second and a half is about how long it takes to generate a mental image. So, if this is cognitive penetration, it's not cognitive penetration that's going to cause any real epistemological problems because it takes so long to do that if you want to avoid any epistemological contamination in anything where you have some control, just make your judgment in the first second. Okay, so it shows something you might call cognitive penetration, but it's not really. But look, here's I think maybe the more neutral thing to say is that when we think about whether cognitive impenetrability holds, we might have somewhat different purposes. Maybe if we are interested maybe in epistemology, it would make sense to define it so that imagery counts, and maybe it is a case of cognitive penetrability. But if you're interested in the science of it, and especially in whether there's a joint in nature, I don't think this impugns any joint in nature. Anyway, we could argue about that. So, I don't have much more time left. So let me move to core cognition, which is something that I've long been troubled by. Okay, so I'll just get into it and perhaps we can talk about it. Okay, so what's core cognition? This is my wife Susan Carey and Elizabeth Spelke's idea that we have certain domain-specific systems with innate perceptual analyzer that identify entities in the domain. Those entities those representations have an innate conceptual role. They are continuous through development, a long evolutionary history. And here's the interesting thing, they have conceptual contents, according to Susan and Liz. So they look like they're somehow, just the very, let's see, did I put iconic in there? Oh, I may have left out iconic. Okay, so the two main things are, and I left out one of them, is that they're iconic and they have an innate conceptual role. But my God, iconic and have an innate conceptual role, it sounds like they're not either perception or cognition. So it looks like they ruin the joint in nature. So let me say, depending on how you count, there are 3 or 4 or 5 different core cognition systems: physical objects and causation, agents and goal-directed action, number, space, and social groupings. And here, I'll just give you a couple of very simple examples. So this is one that this is one of Susan's slides. If you don't know this literature, if you're interested in innateness, which has been a big philosophical topic for many years, you should look at this fantastic work done by this group in Rovereto, Italy, where they have a paradigm of experimentation on chicks. And what's cool about this is they have arrangements with farmers where the farmers give them the eggs that are ready to hatch. And then they can control every single thing that a chick sees, okay? So they know what's innate in the chicks. And what they do is the cool thing here is, this is just one of them. And so one of the behaviors that is most useful is the behavior of imprinting. Now they have found that if the chick hatches, gets out, opens its eyes, and sees a moving thing, the chick will imprint on that moving thing in the sense that the chick will want to huddle next to that thing when the chick sees it again, okay? So the chick opens its eyes, they turn on the lights, they see that, and then the next, then the chick will huddle next to that object, okay? However, they tried occlusion. This is just one. The question they were interested in is occlusion innate. Is the ability to see the occluded figure innate? And this experiment suggested it is. So what they did was they gave the chick a choice between this and this. In this, the chick was seeing an occluder over the triangle. And in this, there was just a gap in the triangle with the occluder above. And this indicates the chick huddling next to this one, okay? Suggesting that the chick saw that as a full triangle. The chick had had no experience of occlusion, right? They can control that. The chick had never seen anything occluded. And that's what's so cool about the experimental paradigm that they have, is that they can completely control. Okay, so, it's in chicks and not in humans. There are plenty of examples. In humans, they're always a bit more complicated. Okay, so one of the cases is this one that I showed you. That's one of the reasons I showed you that display. A approximate numerosity is accomplished by a dedicated perceptual system, but also used in thought. We and other animals reason with numerosities. And here's an example from the animal literature. If birds choose where to forage for food, so they take into account where the food seems to be more numerous, but they also take into account what they predict the other birds will be doing. So they're using numerosities. They have to have a sense of how many birds are where, and if they can see the food source, a sense of the food source. So they use these in a stereotypical way to decide where to go. So here's the idea of why. This is from some of Susan's work. She says, core cognition resembles perception in many respects that distinguish it from other types of conceptual representations. These include the existence of innate perceptual input analyzers that identify the entities in core domains, a long evolutionary history, continuity throughout development, an iconic or analog format. So why you think, isn't it just perception? The answer is because it's conceptual. It has conceptual content. And in this paper by Nick Shea, he says, a paper directed against there being a joint, Susan Carey has emphasized another set of examples which she calls the systems of core cognition. These systems are intermediate between the paradigmatically perceptual and the paradigmatically cognitive. Carey argues that these processes deserve their own category in the psychological inventory. They are neither clearly perceptual nor clearly cognitive. But is it really true? So they're used in thought, but why isn't that just like color, right? We see colors. We have a dedicated color perceptual system. We have color cognition. It uses innate perceptual analyzers. Nobody would claim that color perception is some kind of third category. Color perception is clearly perceptual. The reason is that for color, there's no automatic conceptualization. That's what's special about core cognition. There are innate systems, but that doesn't make it special. There's innate systems for color too. We saw last time, as I explained, and I picked color for this reason. There is not only is there no automatic conceptualization of color. Remember the term Farbendummheit I mentioned? Small children are completely stupid with respect to color. They don't even notice color. It takes years for them to notice color. So there's no automatic conceptualization. Color is the opposite of automatic conceptualization. But look, does that make it a third category between perception and cognition because there's automatic conceptualization? I don't think so. The numerical cognition that those birds are doing, that's just cognition. It's cognition that makes use of perception. We perceive approximate numerosity, but that's perception. The cognition is the relatively fixed conceptual role. So look, here's my take on this. Core cognition goes firmly on the conceptual side. It's not in the middle. It's not a third thing. What's distinctive is that it has a somewhat more fixed functional role and that it's automatically conceptualized. So foraging involves conceptualization, automatic conceptualization of perceptual representations. I mean, maybe somebody can enlighten me, but I'm not seeing any problem with the joint in nature here. So now, is there a joint in nature between perception and cognition? Yes, according to me, and I thank you. Yeah, let's go straight to the question. Sure.
Preguntas. Seba. Thank you very much. I would like to ask you about the role that might play the distinction between.
I would like to ask you about the role that the distinction between perception and cognition might play in the debate between action and perception. So there are some experiments that I think that might be related, but I want just to know your views, because this is also related to attention. So, for instance, in experiments done by Witt, I don't know how to pronounce it properly, W-I-T-T, she claims that perceivers, I mean this is done with professional sporters, perceive, for instance, the golf holes as bigger when they play better. There seems to be, so this is a judgment, I would say that this is a cognitive issue, but then in trying to figure out whether it's a cognitive situation or it's a perceptual situation, she's mainly interested in action. So what she did in one of those experiments, the participants had to judge the distance of an object, and they had some kind of instrument to grab it. Okay? Then the judgment of distance was only modified by having the instrument when the participants had to actually grab the instrument, and she suggests that that has to do with the intention. So only when the participant has the intention, then the perceptual judgment or the perception, she says that it's perception, is modified, and say that there is no alternative explanation, so that than saying that this is a perceptual effect. I think that alternative explanations can be done, but I would go for saying that it has to do with attention, but that would bring us to one of the paradigms about attention that considers that attention is related to action. So attention is selection for action, like Wayne Woods, for example. And in this case, intentions would play a role in attention, and they thereby would play a role in perception if perception is modified by attention. So if attention plays a role. So can you help us or give us your views on these issues? Thank you very much.
Yeah. So Jessica Witt is a student of Dennis Prophet, and this is in the Prophet paradigm. It's actually quite similar to the Hill experiment I mentioned, where the effect only works when you have the intention to climb the hill. There's no effect if you have no intention to climb the hill. So it's a similar thing to that. If you're intending to do something, okay, so here is the problem with, okay, I think these Prophet lab experiments do not properly distinguish between perception and perceptual judgment. No doubt the subjects are making a perceptual judgment that affects their action, but it's not good enough to do that. You have to take some pains to see that it's really perception that's involved. And these are the experiments that Firestone and Scholl have so effectively debunked. They don't even ask the subjects whether they know what the purpose of the experiment is. If the subject knows the purpose of the experiment, then that could influence the subject's behavior. I don't know of a single experiment from the Prophet lab that is adequately controlled. They don't use signal detection methodology. They don't use any of the methodologies that exist that would be capable of doing this. Look, part of it is, I don't like saying this, but I'm going to say it anyway. Almost all those people are not perceptual psychologists. They're social psychologists, and they're not as schooled as they should be in, I'm saying this on, I'm live. Oh no, I'm saying it anyway. They're not as schooled as they should be in the methods of perceptual psychology, so I really don't believe that. Yeah, go ahead.
So, independently of these results, would you please say something on the interaction between cognition and perception, assuming related to the debate on attention as selection for action? So, if attention is selection for action, where selection for action, or
put still in a different way, what do you think about using this kind of evidence to argue against this kind of views? Or are they related, or?
Yeah, so I myself do not think of attention as selection for action, and one reason I don't is that in vision, which is where almost all the attention work has been done, the system that is known to use attention, the so-called ventral visual system in the bottom, goes from the back of the head into the temporal lobes, that system is not the system that directly controls action. The visually guided action is directly controlled from the system in the top of the head. I showed you last time this amazing fact that grip, accuracy, is just as accurate and just as variable at 5 degrees as at 70 degrees off the line of sight. Even though consciously you feel you can barely see the thing off at 70 degrees, the system that controls action directly is and is visually guided action is guided by a system where the effects of attention have not been very well investigated, and it is really quite separate from the effects of attention that have been investigated mostly. So it's not clear to me that it's usually thought, the way the Milder and Goodale people put the distinction is that actually conscious vision is mainly not for action, but is mainly for planning and getting ready for action, the selection of action. The moment-to-moment effecting of an action is much more the province of the dorsal visual system. So, yeah, I'm not sure if that's an answer, but...
questions. The first one is, could you please explain the first slide of your talk, the one with the chicken and the broccoli? We had a debate about how to interpret that one, but...
Yes, okay. That is, I'm illustrating a joint in nature between animals and plants, which I should say, well, go ahead with the second.
No.
Yeah.
Oh, well, the second one is more serious. It's about the experiment involving the dot, the red dot. So I wonder what happens if you give the subjects 3 options rather than 2, because as you run the experiment, you gave us left and right. I wonder what happens if...
Which experiment was this?
The one with the red dot in the middle.
Yeah.
Right, so I'm wondering what happens if you give subjects 3 options, left, right, and same. Because as it is, I'm not sure if it appeared to me that there were more dots on the right side or whether I'm being forced to give the best answer out of 2 bad ones.
I see. Okay, let me say that if you do this in controlled circumstances with the lights off, you will have no doubt that you see the numerosity. I didn't, look, I can't resist the temptation to give you one that works better. If I have it here. Do I have it here? Maybe I don't. I'm sorry. Oh, maybe I do. Let's see. Is it? I don't seem to have the... Oh, no. I'm sorry, I don't appear to have it. So, yeah, there's this thing called the tilt after effect. Well, I guess I'm showing it. But, it really, it's a sledgehammer effect. You really will have no doubt. So, look, this isn't a laboratory. So, the effects that I'm showing on the screen don't work quite as well as they would in a real laboratory. So, but I'll say I am 100% confident that if you experience the effect in controlled circumstances, you wouldn't have any doubt.
The way you define the distinction between
I'm sorry. Okay, one of the criteria you used to define cognition in contrast to perception was in terms of inferences. And so you were saying one of the things about perceptions didn't work as premises. But when you start talking about the logic of perception, it is very clear that these are inferences, right? You need to make an inference to reconstruct the strangely shaped, not octagon. And so there seems to be, that seems to be a good reason to think that they are cognitive. So how do you reconcile those ideas?
Yeah, it's a bit of sloppiness on my part. What I meant was personal level inferences. I don't count computation in the, subpersonal computation as in the visual system is really inference. I'm also quite skeptical about how much inference there is. People tend, there's very little proof that there's any inferences in vision. What we have is that the visual system, quotes, goes beyond the retinal display. People often think of vision as an underdetermination problem. You get some highly ambiguous visual display. There are many different distal arrays that are compatible with it. And people the visual system comes up with the right one. But whether it does it by anything that is an analog of inference, I really have my doubts. Look, maybe there are some analogs of inference going on. I don't think they're actually inference. But my feeling is that that vision scientists have overused that term inference.
But in the case of the occluded image, I mean, it's very hard for me to think that we are not seeing the difference between what we have reconstructed of the figure and what we're actually seeing because it's not occluded. So it seems to me that because we can see the difference, it is because somehow we understand that one of them was inferred and the other one was given.
Okay, so I wouldn't use the word inferred, though.
Yeah, but
I think
why?
the visual system is coming up with the distal stimulus. But whether it does it by inference or by some automatic mechanism, remember I gave you I tried to illustrate this with the convex shapes last time. That was the purpose of
the one that turned around?
Yeah.
Okay.
So, people say that the visual system assumes light comes from above, and wherever it sees the shadows, it infers that that's the bottom, okay? Or that's that is produced by a light coming from above. But there's no evidence that I know of that that's actually inferred as opposed to some kind of an analog process built into vision. I know of no proof or even evidence that there's any steps in an inference of that sort. So that's the point. I'm making 2 points. I'm making the point that the analog of inference is not established. Maybe there are some cases. And the second point is it's a subpersonal process. I wouldn't call it inference even if it was established. The analog was established.
Okay, thank you.
When I say inference, I'm really talking about thought and reasoning.
Yeah, thanks. So you said that some top-down effects are compatible with the joint between cognition and perception. So I'm wondering which effects aren't compatible, and if it's a matter of number, of like there being at least some cases in which there aren't effects, or rather is it a matter of kind, and which kinds those would be? Yeah.
Okay, so first of all, I ruled out the top-down effects in the visual system, intramodule effects. And secondly, I listed those categories of, here, let me find that actually. Where is it? Yeah, these categories. First of all, the relevant thing is what is called synchronic effects. That is, do your beliefs influence what you see as you're seeing it? Now, diachronic effects are certainly there, very big diachronic effects. Your experience changes your perception, even at the level of figure ground segregation. There's no doubt about that. But I think from the point of view of a joint, it's the so-called synchronic at the time effects. Attentional effects are definitely top-down, and the most dramatic of them are feature-based attention, where you're just much more likely to see something with a given feature if you are looking for that feature. So that's a top-down effect, but I don't see that as impugning a joint. It's an effect by which certain representations that are really there, representations that are really responding to the input are amplified. You know, I guess you could, maybe some people will claim that impugns it, but I don't think so. Well, you know, I didn't go into the hysteresis effects. So in the case of ambiguous stimuli, if this visual system is actually producing two interpretations in a bottom-up way, and you are selecting one of those, that certainly doesn't seem to impugn the distinction. And then, of course, you know, imagery is you could argue either way, I think, on imagery. The thing is, I guess the point I'm trying to make is that the cases are I think we can enumerate the cases. The ones that, as I said, I think give me the most trouble are the cases where you have an ambiguous stimulus and it's not clear that the visual system has computed two different interpretations. It's got no interpretations. It just looks like a meaningless bunch of blobs. And then it snaps into place. But, I think we just simply don't know the explanation of that. So that's my take, anyway.
And just relatedly, if everything were core cognition, like, so you place core cognition on the side of cognition, right?
Yes.
But so if we found that it was like that for everything, then that would challenge the existence of the joint, right?
I don't think so, because if every single cognitive kind of thought we did had it relied on a dedicated analyzer, okay, so our cognitive thought all relies on dedicated perceptual apparatus. That doesn't mean there's no joint. It means that cognition is much more kind of inflexible than we might have thought.
Okay, that's helpful.
Thank you. I think I'm still not completely clear about your distinction. You seem to accept, and you showed several slides on that effect, that visual illusions are there independently of our...
Wait, say that again, what?
Visual illusions are there independently of our thought or of our beliefs and so on. And then you claim for a joint, and that seems contradictory in a certain sense. You seem to say that that visual system or the visual array has a logic of itself, like a cognition of itself, a sub-personal cognition. And so the joint would be between a higher form of cognition and a visual form of cognition. Is that your solution of the joint?
No, I think the joint is between vision and cognition, I think that visual cognition is cognition.
Okay. And the joint is between visual cognition and higher cognition, shall we call it, or you don't want to call it that way?
No, it's between perception, vision, and vision. Vision is on the perceptual side.
Sure.
Visual cognition is on the cognitive side.
Okay. And the joint is between those two?
Yeah.
Okay. And joint means that it's the same system, or are two systems working together?
The systems can work together just as animals and plants can work together. So it's like animals and plants. I say there's a joint in nature between animals and plants, although there can be hybrid systems that use both. But animals and plants are different kinds of things.
Okay. You projected a slide that you went very fast through it, but with the epistemological and the scientific. Can you come back to it and perhaps explain it a little bit? I think what I'm asking is very much related to that.
Okay. Yes. So the purpose of this slide was to say, okay, imagery you could decide either way. You could decide from an epistemic point of view that the fact that we can superimpose imagery on perception, and imagery can be, almost anything we want, we can imagine. we can see anything we want. You could have a visual experience of anything you want. So, certainly the traditional concerns of cognitive penetrability were that how can, the terrible problem, how can we rely on our experience? How can our experience justify our beliefs if our experiences are determined, our perceptual experiences are determined by our beliefs? So you might say, okay, imagery really does create a problem for that. Maybe we do want to call it cognitive penetrability. So, but on the realm of science, where the joint in nature is what's occurring, it seems to me that the joint in nature, that is, that the difference in format. So the idea that, so here's the difference in format is perception is constitutively iconic. It's part of what it is to be a percept, is to have that iconic form. Cognition can use iconic, but it doesn't have to. So that's the way that's the key thing in the distinction. And what I'm saying is that really does work. Okay, so you can use your cognition to produce an image and superimpose it on the things in the world, but it's a cumbersome process. It's hard to do. It takes 1.5 seconds to do it. So I just don't see it as well. But I think you could go either way. I think maybe then it becomes something of an issue of practicality, maybe, or your purposes. I guess what I want to say is this interest relative issue.
Thank you.
I have 2 questions. Well, I want to first ask about what do you think that are the vehicles that are involved in cognition, the vehicles of representation? Because I have in mind the theory of Marzo, and for Marzo, the connection between perception and cognition is possible because they are using the same kind of representation. So I want to ask you if you think that so.
Yeah. Okay, I have to admit I don't know Barcelou's views very well, but my impression is that he has a kind of Berkeleyan idea that concepts are just congeries of perceptions, something like that. So, I mean, I don't agree with that view. I think, I know he's in the ballpark of thinking that there's no real border between perception and cognition because cognition is just saturated with perception. But I don't really fully know his views, I'm afraid.
Do you think that there is a model representations involving cognition?
I think there's a what?
A model, like abstract representation.
Yes, that's right. Yeah, so I don't agree with that type. The kind of, it's really British empiricism, so as I understand it.
But how then they interact? How they interact the representations that are involved in perception with that are involved in cognition?
Well, that's really a very big topic. I think that the way the sort of maybe abstract answer is we conceptualize the percepts and use them in our thought. I don't know what conceptualization of percepts could amount to in the Barcelou type of system. It's a bit of a mystery to me, but then I haven't studied that work, so I don't really understand it.
Okay, thank you.
Well, I was going to ask something about Barcelou too, but it doesn't matter anymore. Well, the second question was about what do you think about hypnotic effects, like when your beliefs seem to be affecting the way you perceive things, like the weight or something like that.
I don't really know much about hypnosis, but it's an interesting thing to look at. I have read a little bit about it. I just don't know. I'm afraid I can't answer. I just don't know the science of hypnosis. I agree that and I don't know of any controlled experiments where they they make an effort to distinguish between perception and perceptual judgment. So I don't know if anybody has really made an effort to make that distinction in the case of hypnosis. It's true subjects say things about what they're perceiving that suggest that the hypnosis is acting on it, but we have too many cases where when you focus, when you actually do some serious experiments, you find that it's judgment, it's not perception. Even some of the most famous cases. In fact, I actually have if there's time at the end, I'll show you one of the most famous cases that turned out to be probably not right.
I couldn't come last time.
It's not working.
Yes,
Here it is.
I couldn't come last time, so I'm not sure if you have answered this question already. But my question is this: is what do you mean by a joint in nature? No, the example you give of a joint is of a knee, right? Of a human knee. So what's the analogy between a knee and what you call a joint in nature?
Yeah. Okay. So I actually have part of the talk on that question, and which I skipped. So you're right. I didn't answer that. What I have in mind are the idea of natural kinds. That there are natural kinds in the world. My example, illustrated by the first slide, is between animals and plants. So really quite different natural kinds that we think of as each of them is a cluster of features that makes it differ from others. So let's see if I can so look, here's an example for animals and plants. I don't know that this is going to help at all. So here's a list of features of animal. I don't know how visible that is. Not very visible. I should have made it bigger. Of animal cells versus plant cells. They both have cells. There are some features that are actually, many of the features are differences of degree. And of course there are many living things that don't fit in either category. So animal cells don't have a cell wall. Animal cells don't have chloroplasts. There are features that cluster together that distinguish, different parts of nature. That's what I mean.
Any two things that are different and have different clusters of properties have a joint between them? Or
no, I think there has to be some kind of principal difference, and I think in the case of perception and cognition, the principal differences are the clearest one is format, iconic versus propositional, but I think there's also a considerable difference in functional role. Of course, that's very controversial. I think the idea of informational encapsulation is true with certain exceptions, but I think you can specify a functional role for cognition and perception that are really quite different from one another.
Yes, I think I am a little confused about the goal of today's talk, because yesterday you were arguing that perception and cognition are two different systems, and perception can work without conceptualization. But today you are showing that there are some penetration in some cases, and there are perhaps they can work together. Now, my question is, do you think that most of our experience are those in where these two systems work together, or they jump from one system to another system? If the answer to the question is normally they work together, why we don't start looking which are the different functions in our normal experience, and then take as something abnormal when they come apart.
Okay, so I agree that they work together in normal experience. Normally we certainly humans, we conceptualize many of our percepts, but that doesn't mean that you can't you can't see the operation of really quite different systems that are cooperating. Two people, for example, in a close relationship will communicate in a very interactive way, but there's still a joint in nature between one person and another. So mutual interaction. So as I said last time, I believe there are examples in which is just perception, like the jumping spider I mentioned. No cognition, probably no cognition. Very sophisticated perception too. So there can be perception without cognition, I believe. In creatures like us that have cognition, those two systems work together. I agree, but that doesn't mean that they're not really quite distinct systems. Just as your heart and your liver work together, but they're distinct. There's a joint in nature between hearts and livers.
Thank you. Well, I want to ask you if we can use an evolutive argument to understand the joint between perception and cognition, or if there is no useful use on an evolutive argument to understand this joint.
What kind of an argument are you talking about?
An evolutive argument, like the evolution of the perceptual system has an impact in the cognition of, I don't know, color, shape, or things like that.
I see. Uh-huh. Well, I certainly agree that the two systems that we have evolved together, mutual evolution, interactive evolution. I agree with that, but I really missed part of your question.
I was thinking that because when you present the evidence of the different.
Thank you. When you present the evidence of a different perception of the red color in the experiment, there is also evidence that the perception of red is relatively new in primates. So maybe that was an explanation that why we perceive red in a different way that we perceive the other colors. So if there's like
What's the explanation of why we perceive red? I think I can understand you better without the microphone.
Yes, there's evidence that the perception of red is relatively new in primates because these sensors specific to perceive red is relatively new in many primates. Also, many primates doesn't have this kind of red perception because doesn't have the specific cells in the retina. So maybe if we think in the evolution of the species, that if this kind of argument, this kind of evolutive arguments could help us to understand the joint between perception and cognition.
I see. Well, I certainly agree that a good idea for people in that Gegenfurtner lab would be to look at the evolutionary considerations to see why their phenomena work for yellow and blue but not red and green. But that's all within the visual system, according to me.
Yeah, thank you. I would like to ask you also about the notion of joint in nature, because some of the assumptions at the very beginning and even some of the evidence that you were presenting seems not to be required for a certain way of understanding the joint in nature. So if I follow you properly, what you really want to show is that there are like two different kind of representations which differ at least and most probably in functional role and format. So I think, but maybe I'm completely wrong, that compatible with this idea, so cognitive has one functional role and one format, perception has an iconic format and a different functional role, is the fact that there is the modularity that Fodor postulates is wrong, so that there is some kind of cognitive penetrability. This is compatible with a joint in nature, if by joint in nature we understand these things. I mean, you might be also willing to make a stronger claim. Is that correct, or I'm making something?
Okay, so here's the thing. As I was indicating before, I think that the notion of cognitive penetrability isn't antecedently clear, that your interests can decide whether you count something as an instance of cognitive penetrability. So what I would, for my purposes, what I would prefer to do is talk about cognitive penetrability from the point of view of a joint in nature. So many of the phenomena I mentioned, I guess you could count, certainly imagery you could count as cognitive penetrability, as Fiona McPherson does in her paper on cognitive penetrability. But from the point of view of impugning a joint in nature, I don't think it does impugn it.
Okay, so without using the word cognitive penetrability, the joint in nature is compatible with non-modularity, so non-absolute. By module I mean something that cannot be, so completely isolated modules, right?
Okay, I do not think that perception is isolated. There's, as this gentleman here has pointed out last time, there's all, the brain is just, there's interconnections almost everywhere. And you didn't point out, but you probably would have, is that the feed back from cognition to perception is, the feedback in the visual systems is huge, bigger than feed forward. Now, there are some explanations of why that is, that are compatible with, I mean, I can say a little bit about why I think that is, but yeah, maybe I'll stop there.
I suspect there should be a very obvious answer to my question. But what happens when people train to acquire a different perception of things? I'm thinking about musicians. When you learn music, you learn certain concepts like, I don't know, interval, pitch, tone, and you apply those concepts in your perception of a musical thing, I mean a symphony, for instance. And I think that you acquire a new perception if you use those concepts. For instance, you can detect certain intervals when you train to detect those intervals, but you need the concept of a fifth or a fourth or pitch. I mean, in that case, it seems obvious that if you have those concepts, your perception of the musical thing can change. What happens in those cases?
Yeah, so you're right, you're absolutely right, and wine tasting is another such case. You learn to taste certain things in wine, and then your perception of wine seems to be quite different. Okay, so what I say is that those are, remember I made the distinction between diachronic effects of cognition on perception and synchronic. Those are diachronic effects, they're over time. And there's no doubt that the perceptual systems change over time in response to cognitive demands and just experience. But the joint in nature is an online thing. It's, do my perceptions now depend on my cognitions now? So that's what I was arguing for, that they don't accept in certain circumscribed ways. But I certainly agree that over time they do, and I don't know that this is much studied how it works. There's no doubt that the perceptual systems are very plastic.
Good day.
I was wondering if you think there are constituents to this joint, because we've been talking about it recently as a process, as a dynamic process, as a biofeedback process between perception and cognition. And I was wondering if there are elements other than perception and cognition that are feeding this process. For example, I don't remember which slide it was, but you said, okay, this might be different if you have an upset stomach. So could it be that there are other constituents of this process, for example, pain? What do you think?
I don't know enough to answer that. I'd be surprised if pain didn't affect perception, but it might affect it by draining off some attention. You're asking a direction of question that where I just don't know enough to answer. Well, I guess I'm sure you're right that there are some effects on both perception and cognition of say pain, but they might be entirely subsumable under attentional issues. I just don't know.
Thank you.
Well, you suggested about a joint nature between perception and cognition, but I was wondering if in time we can talk about a joint in nature between different subsystems in cognition, and I don't know where do we stop distinguishing between systems.
Yeah. Well, this is the subject of a lot of literature. So the term, if you want to look it up on Google, the term is massive modularity. So Dan Sperber, a French philosopher, anthropologist, has argued strongly for what he calls massive modularity, which is, some kind of modularity throughout the entire brain. There are many cognitive faculties that are, he thinks, distinct modules. I don't really know this literature very well, but there's certainly a lot of people thinking about that issue.
Thanks.
Hi. I think the question I'm going to ask is very, probably it's obvious, but I don't know almost anything of philosophy of mind. So my question is that what would the implications be if the answer to the main question was negative, and the main question I understood was that is there a joint nature between perception and cognition, and you said yes. So I was wondering what would happen if you would say no.
Well, I think it would really make a huge difference to our view of the mind if we thought it's all, one kind. There aren't these two wildly different faculties, and it would certainly make a huge difference in epistemology. I mean, we really have to confront the issue that that Susanna Siegel is very concerned with, just with regard to whatever limited effects of cognition on perception there might be, namely of how we can think of the justificatory role of experience if, in the most extreme case, if our theories and beliefs that we think of as confirmed by the evidence we have actually determine what the evidence is. So that would be a major issue, and actually what Siegel has talked about is also some quite interesting ways in which the collapse, if there is a collapse of the joint in nature, has an effect on the way we should be thinking about ethics and political philosophy. And the idea is in terms of, and this is actually important even if there is a joint in nature, but the increasing ideas now about the perception of moral properties and how we can use our perceptions in deciding what is the right thing to do and what's good and what's bad. So the basic idea here is that if all of our thought about what the options are and what's good and what's bad and what's right and what's wrong are colored by our perceptions, and then our perceptions are themselves partly determined by our beliefs about what's good and what's bad and what's right and what's wrong, then we have to consider the impact of that on our moral thinking, because maybe our perceptions can't be relied on, and our conceptions of the alternatives open to us can't be relied on if they are affected by our moral views. So I think actually there would, another area in which I think there would be ramifications is aesthetics. So, I mean, in the extreme case, maybe what you should do in an art museum is bombard people with propaganda in a certain room and change their experience. I think that the issue of whether there is a joint in nature is, in principle, has consequences for much of many areas of philosophy and art and literature and many other aspects of the humanities. Well, look, actually, of course, I didn't even mention the most, the most significant or at least salient case, which is the issue of racism. I'm sure you're all familiar with these, gun and wrench experiments. I don't know, maybe not. Okay, I have those. Everybody should know about this. I'm sure I have this here somewhere. Oh yes, here we go. Oh no, here we are. So this is work first done by Keith Payne. So the idea is he shows people a black face or a white face, and then a tool or a gun, and then a mask. And then what he finds is if they have a lot of time to think about a slow response, they're only a little more likely to say to say gun when they see a black face. But if they have to do it quickly, they're much more likely. So you see the false gun responses when they've seen a black face are substantially higher. The false tool responses when they see a white face are higher. So this is a pretty dramatic effect. And actually these aren't quite as big as some of the other effects he gets. So look, this is a big issue in our thinking about race. It's another way in which politics and ethics come into this. Now, interestingly, this is a case where, and I don't know that I have this on this, this is a case where it seems not to be a perceptual effect. And that's what's interesting, so let me just see if I can find that. So here's what he did. No, that's not. Let's see, it says a better version of this. Yes. So here's what he did. He had a version of this where there was a very large race effect, and then he asked subjects to say whether they, in the case where they say see a gun, he said. He had a three-way distinction. Did you see features of the gun? That's the C response here. Or did you just guess about features of the gun? That's this. Or did you just know it was a gun without seeing features? Okay, that's this. And you see the race effect is mainly in the no. That is, the just know without seeing features, suggesting it's a judgment effect. They didn't actually see like the gun or the glint on the barrel or anything like that. So it suggests it's not an effect on the perceptual level, it's an effect on judgment and belief, not perceptual phenomenology. It's an interesting thing So it's another case where there were reports of effects on perception that turned out maybe not to be effects on perception. But again, it illustrates, in answer to your question, it illustrates the importance of the issue in that it is relevant to racism. So I think, we're dealing with a very important issue and something that it's very worthwhile for philosophers to think about.
Yeah, so I think you're right that, or at least this is how I'm thinking, let me know what you think. You're right that there's an interest relativity in the issue here. And I can see why, if you want to focus, if you want to try to figure out whether there are interesting systematic differences between perception and cognition, you might put together all these kind of arguments to say, yeah, there's an interesting difference here, and I can do work with it, and this is interesting, and that sounds pretty persuasive. But also there may be someone that wants to know what are the commonalities between these two, and what makes it the case, in virtue, what is it about perception that allows to conceptualize it? And that is compatible with what you're saying, and so maybe, I don't know, an answer to that question could be there are some format features that are common, even if there are some that are distinct, there are others that are common, and if that's the answer, then there might be a version of Susanna's worry at that other level, even if the way Susanna is pressing the issue might be well resolved by the difference here. One might wonder, well, am I justified in ascribing to the world those things that, or those features that are really common between the format in the perception and in the conceptualization? And maybe there the answer is, well, not so clear, because there will be a vicious circularity at that other level. So I just want to know if this is...
Yeah. Look, I think it's an interesting question. I think these format differences are very hard to get experimental evidence about. And the issue of what happens when a percept is conceptualized is really hard to get any evidence about. Whether it's, I guess at one extreme you can have the view. What happens when you use an image in your thinking? One extreme, you use the image and you use it with a different role than it had when it's in the perceptual system. But, maybe it changes format in some way. I don't know, I've wondered about this, and I don't know any experiments that can help to decide it. If anybody knows of anything, I would love to know about it.
Have you considered the concept of affordance by Gibson in the sense? Because I'm getting the idea that it's an excellent example of a joint of sorts. Yeah. Either within a purely perceptual vision or perceptual format, or the joint between cognition and perception.
Yeah, no, I think that's another really interesting issue. Okay, I have some views on this, but they're not very well founded, I think, but I'll tell you what I think. I believe that those in the case of visual affordances, they're mainly dorsal visual system representations. Consider, for example, what it looks like when you see an object, say a cat moving behind a fence, and you see the whole cat. So I think what you're seeing is some kind of almost unconscious representation of a whole object. And now I think that these more or less unconscious ones are not intrinsically related to action. But anything that's close to you, you sort of feel like you could reach out. They do seem to be somehow connected with motor systems and motor plannings, as in, for example, mirror neurons and things like that. So that's an area that I would like to study more.
Yeah. Well, actually, probably the frontal lobe is essential for affordance, because it's like an action system that sets the organism in relation to the object and how it can manipulate it and so on. So it's, I think both systems, the ventral and the dorsal, convey in the frontal to provide the affordance of the object. So it's almost the whole brain.
If you know some good things on affordance that I can read, I would love to read them.
Sure.
No, it's it's a really interesting issue.
Any other questions? Thanks very much.
Just very short follow-up. So I'm going to try to
present the question in a present way. So if, as you suggest, the ventral and the dorsal confront in the frontal lobe to form the representation of the affordance, that would be pretty much something you would not be willing to accept. Because of the kind of the way in which the representations are organized. So some people think that vision processes has more to do with posterior areas, and some people think that frontal areas.
Well, not all frontal areas. The frontal eye fields are widely thought to be part of the visual system.
So those are.
Yeah.
Okay. Yeah. Sorry. Thank you.
But I don't know to what extent it's the frontal eye fields that are mainly involved in affordances. What? Ah, okay. All right. Okay. I'm not going to say anything about this without investigating further.
What you can use to get invoices or facturas.
Ah, very good.
Yeah?
Okay.
So you don't have, just
yeah.
to the way.
Okay. Okay, I sent the email to that restaurant. I hope that...
I'm sure they will